Okay, so tonight's homework is to choose a division problem and show 4 different ways to solve that division problem. The requirements were that you needed to choose a 3 to 4 digit dividend and a 1-digit divisor. So the number I chose was 742 divided by 6. So the first way I'm going to show it is with an area model. So I'm going to draw a rectangle. I'm going to label the inside of my rectangle 742 because that is my area, that is my dividend. I'm going to label the outside 6 because that is my divisor, and it's also my width if we're looking at a rectangle. I'm going to ask myself, does 6 have anything in common with 742? The question is no, the answer is no, it doesn't. So I'm going to need to decompose the number 742. So I draw another rectangle. I'm still dividing by 6, so I label 6 as my divisor, and I start taking out the largest numbers that I can by breaking apart the number 742, which, if we remember, that's decomposing the number. So I start at going by tens, in this case going by hundreds. I go 700, no. 600, yes. 6 has is compatible with 600, so I label 600. Then in class we've been talking about, it's like how many tickets we have left. If we're at Chuck E. Cheese and we have 742 tickets total, and then we spend 600 of them, we're going to have 142 tickets left. So we're going to continue decomposing the number. So 600, then I ask myself, what do I have left? 142, so I'm going to do the same thing. Does 142 mean anything for 6? No, they aren't compatible. What about 100? No, and now I'm at 100, so what do I need to do? I need to think of the multiples of 6. So first I think of 6 times 1 is 6. It's going to be too low. 6 times 2 is 12. I see 120, right? So I'm going to put 120 because I see that 12 and 6 are compatible numbers. So now I have 120. So I have 600 plus 120, which is 720, which means I have 22 left over still. So I know 22 is not compatible with 6, so again I have to think of my multiples of 6. 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24. 24 would be too large because again my number is 22 that I'm left over with. So I'm going to choose 6 times 3 equals 18. And then how many do I have left over? Well, I have 4 left over. So I'm going to draw those 4 that I have left over so I don't forget about them. This is the area model. I'm then going to go to, I'm going to solve this, but I'm going to go to distributive property to solve it so that I can see what I'm dividing by. So when I go to the number bond, I put 742 inside my full number bond. That's my whole number that I'm dividing. The way I decomposed it was 600, 120, 18, and then I have my remainder of 4 more. So I'm just going to need to remember those at the end. So 600, I'm going to divide it by what? What was my divisor? It was 6. So I'm going to use distributive property by using my decomposed numbers, and then I'm going to divide those by the factor. The factor is 6. In this case, it's my divisor. So 600 divided by 6 plus, we're adding that, 120 divided by 6 because each one of them has to be my factor, plus 18 divided by 6. Again, my factor is present in each one for my distributive property because I'm distributing my factor, my divisor, to each of my decomposed parts of my dividend. So 600 divided by 6, I know, is 100 because I looked at 6 divided by 6 equals 1, and then I have 2 zeros left over. 120 divided by 6 is 20 because I know 12 divided by 6 is 2, and then I have 1 0 left over. And then 18 18 divided by 6 I know is 3 because that's one of my basic division facts. I'm going to add these together and find out that 123 is my quotient. I can't forget about that remainder I have, so I know it's going to be not 123, but it's going to be 123 remainder 4. So that is also a part of my answer. So I'm going to use this information that I found from distributive property. This is my distributive property right here because I'm distributing my factor. And then this is my number bond because I have my whole number and I'm showing the separate parts. So I'm going to come up over here and I'm going to label the rest of my area model because I now know 600 is divided by 6 100 times. 120 is divided by 6 20 times. And again, I'm getting the information from right here. 18 is divided by 6 3 times with my remainder of 4. So I know that this equals 123 remainder 4. Okay, so now it's time for partial quotients. When I go to partial quotients, this is when we call it the hangman. In class, we're drawing our partial box to show our partial quotients. We put our dividend inside, we put our divisor on the outside, and then we ask ourselves, how many groups of 6 can get us the closest to 742? Well, I know 6 times what equals 742? Can 6 times something equal 700? No. Can 6 times something equal 600? Yes, I know something can. I already know that from here and here as well, that 6 times 100 will equal 600. Then I'm going to subtract to see how much I have left that I still need to divide by 6. 2 subtract 0 is 2. 4 subtract 0 is 4. 7 subtract 0, 7 subtract 6 is 1. Now I have 142. Again, I'm going to do the same thing. How many groups of 6 can get me the closest to 142? Well, I know it's not going to be 142 because there's nothing compatible. So I'm going to go to 100. No, nothing's there, so I'm going to think of my multiples of 6. 6 times 1 equals 6. 6 times 2 equals 12. And 6 times 3 equals 18. I know I can't use 18 because that would be larger than my 14. So I'm going to go back to 6 times 2. But I'm not just going to have 2 because I have in my hundreds place. So I'm going to add that additional 0. 6 times 20 equals 120. Then I'm going to subtract. 2 subtract 0 is 2. 4 subtract 2 is 2. In order to get my next partial quotient, how many groups of 6 can make 22? Thinking of my multiples of 6, 6 times 1 equals 6. 6 times 2 equals 12, 6 times 3 equals 18. That's close, but I want to go one more multiple just to make sure that I'm going the greatest groups of 6 I can. 6 times 4 is 24. Nope, that would be too large, so I'm going to do 6 times 3 equals 18. Then I'm going to subtract. Rather than doing regrouping, I'm going to put that number in my head, 18, and I'm going to count up. 18 and 2 more would make 20. Adding 2 more would make 22, so I know 2 plus 2 is 4. So 22 subtract 18 equals 4. Now I come over here to my partial quotients and I circle them. And I get 100, 20, and 3. So I'm going to put 100 over my hundreds place, 20 in my tens place, and 3 in my ones place because I added my partial quotients. These are my partial quotients. Then I need to come down for my remainder, and my remainder is 4. That is partial quotients. The last one we're left with is standard long division. I'm going to put my dividend, 742, inside. My divisor is 6. I'll put it on the outside. I ask myself, how many groups of 6 can make 7? Well, only one group of 6 can make 7, so I'm going to put 1 over the hundreds place. 1 times 6 equals 6. 7 subtract 6 equals 1. Again, I'm using the divide, multiply, subtract, bring down, repeat, or remainder. Some people use daddy, mommy, sister, brother, and Rover, like the dog's name, to remember the order that we use for standard long division. So we've already done divide, we've just done multiply, we just did subtract. Now it's time for bring down. We bring down the 4 and now we ask ourselves, how many groups of 6 can get the closest to 14? 6 times 1 is 6. 6 times 2 is 12, and I know that's going to be the closest I can get. 2 times 6 equals 12. Now we're at subtract. 4 subtract 2 equals 2. Brother, bring down. 2. How many groups of 6 can get us the closest to 22? 1 group of 6 would be 6. 2 groups of 6 would be 12. 3 groups of 6 would be 18. 4 groups of 6 would be 24, which would be too large. So I'm going to use 3 groups of 6. 3 times 6 equals 18. And again, I should be realizing, oh, I saw this over here. 22 subtract 18 equals 4. I have the same problem here. 22 subtract 18 equals 4. If I put 18 in my head and count up, I could go 18, 19, 20, 21, 22. So then my answer is 4. Again, I get the same answer.